In this video, we have some radical expressions to rationalize the denominator and to simplify. This is the main one here, but I want you to look at the more basic ones first before you tackle this one. You can pause the video as I go through this. Okay, so again, you can pause the video as we go if you want to try it on your own. So this one we want to rationalize. So obviously we want to eliminate the radical from the denominator. The only way we're going to do that is if we can make this radicand into a perfect square. So here we just multiply by the square root of 7 and the square root of 7. So because we have square root and a square root, we can just multiply the radicand. So this gives me the square root 49. And on top we have 14 times the square root of 7. So now 49, of course, is a perfect square. The square root of 49 is 7. So we can mark this out. And then we simplify further. 14 divided by 7 is 2. So the final simplified answer then will give me the square root, or twice the square root of 7. So the denominator is just a 1, so we can write it as 2 radical 7. And that's the simplified form. In this case we have, in number 3, we have a cube root in the denominator. So here we want to make the radicand a perfect cube. So we need 3 factors of 2 to make it a cube. So we could multiply by the square root of 4. That's 2 times 2. So this will give us, and of course we're going to multiply on top also by the square root of 4. I'm sorry, the cube root. Four. Multiplying these here out will give us the cube root of 8. And of course that's a perfect cube. Cube root of 8 is 2. And then just reduce it here. 2 into 20 will go 10. So we get 10 times the cube root of 4. That's the simplified form. We go to number 2. This one we have the square root of 7 minus the square root of 3. So we need to actually wind up squaring both of these in order to eliminate them. The best way to do that is to multiply by what is called the conjugate, especially when you have a square root. So I'm going to multiply the denominator by the square root of 7 plus the square root of 3. I can do that as long as I multiply the numerator by the same thing. So this then will be the square root of 7 plus the square root of 3. Now had this been a plus here instead of a minus, then I would make this a minus. So in other words, I want to use the fact that if I have the difference and the sum of the same two terms, in this case a minus b, a plus b, gives me the difference of the squares. So this would be a squared minus b squared. So in this case, it'd be the square of this minus the square of this. So radical 7 times radical 7 is radical 49. Square root of 49, which is 7. Radical 3 times radical 3 is the square root of 9, which is 3. So 7 minus 3 is 4. So the denominator will end up with 4, and then I have 12 on top, so 4 into 12 will go 3 times. and then I still have this multiplied. Again, the denominator is a 1 now, divided out. I just leave it in this format. You can multiply through by the 3 if you want. Right, this is 3 square root of 7 plus 3 times the square root of 3. In this form here, and that simplifies it. Now the first one's a little bit more involved. So you want to take some time again, try to simplify it, because this is a cube. So I can't just multiply by the cube root of 5 here, because I'm still going to have a cube root of 5 over here. So what can I multiply this by? With the square root, it was just the conjugate. Again, if this had been a radical 7 plus radical 3, it'd be pretty much the same thing, except I'd multiplied both sides up, the numerator and the denominator rather, by the square root of 7 minus the square root of 3. Just the opposite of the sign here. This one, not so simple. But this is what I'm going to do here. I'm going to multiply by the cube root of, so the cube root of 25 plus the cube root of 5 plus 1. And the numerator by the same thing. Okay, so this is going to go right there also. Let's see if this eliminates this radical. So let's do this. Let's multiply these two out. So I'm going to multiply by, using distributive property here, by the cube root of 5 throughout here. So this will be the cube root, and the cube root. So multiply that out 5 times 25 is 125. Plus, multiplying again by cube root of 5. Now the next term, that gives me the cube root of 25. 5 times 5, okay, plus, and the cube root of 5 times 1 is a cube root of 5. Now let's multiply everything on the right parentheses there by negative 1. So negative 1 times cube root of 25 is negative cube root 25. Negative 1 times cube root of 5 is a negative cube root of 5. And negative 1 times 1 is negative 1. These cancel out. This goes to 0. Cube root of 5 minus cube root of 5, that goes to 0. And of course the cube root of 125 is 5. So I wind up in the denominator with 5 minus 1. This of course is equal to 4. And then I have an 8 on top. 4 into 8 will go 2. And that of course is multiplied by the same thing here. So again, 4 into 8 will go 2. And then it's multiplied by this expression right here. So let me just clear this. This then should equal, simplified answer should be then 2. And then this is multiplied by the same thing I multiplied the denominator by, the cube root of 25 plus the cube root of 5 plus 1. This is your simplified answer. No radical in the denominator. The denominator is 1. The other radicals that we have are simplified as far as we can go. That's your simplified answer. Let me know you figured this out, especially if you're taking algebra. And this is the way I did it here. Thinking of this and saying, well, we have a formula for the difference of cubes. And of course sum of cubes. So we know that a cube minus b cube factors into, the first factor is the difference of the cube roots, a minus b. And then the second factor is the square of the first term here, a squared. Opposite sign, the product of the two, plus the square of the second term here, in this case the b. So what I looked at is this. I looked at 5 minus 1. I do it this way. 5 minus 1 is equal to, I'd write this as the cube root of 5 cubed. That's the same thing. Because if I cube the cube root of 5, it gives me 5. And of course the 1 is a cube. 1 to the 30 is 1. So I say, okay, let's treat this as a difference of cubes. And what would be the first factor here? Well, what's the cube root of this? It would be the cube root of 5. So if I look at this right here, cube root of 5 cubed minus 1, treat that as a difference of cubes. The first factor then, according to the formula, would be the cube roots of those two terms, difference of. So we get this. And then the other factor would be, based on the formula, the square of the first one. So if I square this first one, it simply squares to 5. So this would be the cube root then of 5 squared, which is 25. And then it's the opposite sign, plus the product of those two terms, cube root of 5 and 1, is the cube root of 5. And then plus the square of the third root. 1 squared is 1. And this is how we know to multiply by this. Because if you multiply this out here, it gives me this, which is another way of writing this, which is 5 minus 1, and that's why the answer comes out to 4. Thanks for watching. We'll see you next time.